So in the last class, we were looking at the formal definition of a Turing machine and related formal definitions. Today, let's look at a couple of examples of Turing machines with their state diagrams. Okay, so let's do it in the next page. So build a Turing machine M1 that decides the language L. Decides means basically it recognizes, not only recognizes the language, but ensures that it either accepts or rejects it. Okay, it will never get into an infinite loop. So that is what decides means. So we need to build, for some languages we can decide them fully, for some other languages they may end up in an infinite loop. Okay, so we want to build a Turing machine. This language, you can build a Turing machine which completely accepts or rejects. If it is valid, it will accept. If it is invalid, it will reject. That's it. There is no need of infinite loop here. Okay. Done. So the language is 0 power 2n, 0 power 2 power 1, where n is greater than or equal to 0. So what do we mean by this? Since n is greater than or equal to 0, so if n is 0, it will be 0 power 2 power 0, that is 0 power 1, that is 1 0. If n is 1, it will be 0 square, that will be 2 zeros. If n is 2, it will be 0 power 4, that is 4 zeros, and so on. So this language will consist of strings made up of zeros whose lengths are powers of 2. So it will consist of only strings of length 1, 2, 4, 8, 16, and so on. Not just even numbers, not even numbers, only those even numbers which are powers of 2. So it will consist of only those length strings. Okay. So any guesses on how to build a Turing machine for this? We have an infinite tape. We have a read-write head which can go left, right, overwrite a symbol. It can go left, right any number of times. So how to build a machine, build a Turing machine that accepts only strings that have length which is a power of 2 and reject all the other strings. Any idea? Will epsilon be a part of this language? Empty string? No. Why? Because it's not just 2 power n, it is 0 power 2 power n. So 2 power 0 is the minimum, which means it makes it 0 power 1. So minimum 1 0 it will have. Okay. So epsilon is not part of L. Okay. Yeah, but how to do it? How to build a machine that recognizes this language? If I give any even number, how do I distinguish between an even number? See, odd number, even number, we can distinguish. But within even numbers and powers of 2, how do we distinguish? Not every even number is a power of 2, right? So how do you distinguish between even numbers and powers of 2. Other than 2, it has. Even number also has. That's true. But if you take 16, which is a power of 2, that also has 4 as a factor other than 2. Yeah. Log to the base 2. Okay. But log to the base 2 is basically what? Can you break it into some other operation? It's not just log to the base 2. Log to the base of that number will be an integer. Okay. So, but what is log to the base some number? Right. The reverse operation will be? No, this is what you said, exponentiation. Yeah, number of times you are raising 2 to get that number. If you start from the number side, what should you do? Yeah. Exactly. We should keep dividing it by 2. Raising 2 means what? Multiplying 2 so many times. When you start from the number side, you should divide that number with 2 so many times. Right? So suppose if I start with some even number, say 12, I divide it by 2, I get 6. I divide it by 2, I get 3. I am done. I got an odd number. It's not a power of 2. Okay? But if I take a power of 2, say 32, I divide it by 2, I get 16. I divide it by 2, I get 8. Then 4, then 2, then 1. So an even number is said to be a power of 2 if you repeatedly divide it by 2, it ends at 1. If it ends at any other number other than 1, obviously it will be an odd number. It can end at 3, 5, 21, whatever odd number it ends at. It is not a power of 2. That which is not a power of 2, even if it is an even number, if you keep dividing it by 2, it will definitely end at an odd number other than 1. That's it. Like 12 ended at 3. Some other number will end at some other odd number. Okay. The only odd number which is allowed is 1 to say it is a power of 2. Okay. So this is a power of 2 and this is not a power of 2 because it is ending in 3. Okay. So now given this clue, can you think if I am given a string of say 32 zeros, how do I find out that it has, we don't even need to know the exact number, 32 or 16 or whatever. It's a power of 2 or not. That's all we need to know. How do I find out whether the string has power of 2 zeros or not? We can't do all those operations. We can do in principle in a Turing machine, but then that will be, that in itself is a different Turing machine problem. Like how do you add two numbers? How do you multiply two numbers using a Turing machine? How do you divide a number with other number using a Turing machine? That's a different problem in itself. Because even if you count them and you write a number, that number is only a symbol for a Turing machine, like a dollar, like a hash. That number is also a symbol. That number doesn't make any sense to the Turing machine. Okay. So 0 is a symbol. Instead of 0, you can have A also. Instead of A, you can have whatever other symbol also. So you need not really count the total number of zeros in principle, but you can still understand whether it's a power of 2 or not. Like even odd. You don't need to know the exact number of, like in DFA, we can build a DFA to find whether I have seen even number of A's or odd number of A's. But I need not exactly know what is the even number, what is the odd number. Okay. So basically you're saying come from both directions, cross. What should I do if I come from both directions? Ah. Hmm. 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 It will only tell me whether it's an even length string or not. It will not tell me whether it's a power of 2 or not. Exactly. Yes. So how do I ensure that I discard multiples of 2? You see, I'm giving you a clue. Like if I start with 32, am I directly going to 1 or am I going through intermediate numbers? This is the clue. Which is a whose length is a power of 2. Do you immediately need to decide that it is a power of 2, or you can go through intermediate steps? Right. Very good. Yes, exactly. So how do I make the length of the string half? Replace what by another symbol? Which 0? There are everything is a 0 there. Crossing? But it will give me whether it's even or odd. It will not tell me if it's a power of 2. I need to half it. Okay. Fine. Okay. So what you're saying is uh, fine. That is one method. Yes. So what you're saying is, suppose if I have 6 zeros, so I cross this, I cross this, I cross this. Now I discard this half. Now I have these. Okay. But discarding means what? Crossing? You already crossed them. Yeah, okay. Got your point. Maybe we replace these crosses again with something else, again with zeros, right? Yeah. 0, S0 will go to S. Yeah, that's the grammar part. But you need to think from the automaton side. We have both sides, right? Grammar side and automaton side. Here we are discussing automaton right now. What is the grammar for this? That's a different thing. We are not discussing that. We don't have time for that. But you are close, okay? But there's a slightly easier, different method. In this case, this will also work. But then we need to ensure that first I need to replace all zeros with one symbol. Then I need to replace this first half with different symbols, right? And then I need to keep track of the symbols that I'm using other than the blanks. Okay, like how do I know this is the first symbol, this is the last symbol? Because I'll have blanks here. Okay, and how do you know this is the half? Because I already crossed this, so I know this is my half. This is the half part. Okay, but I would have crossed these also. Now I replace these crossed symbols again with zeros. Again I repeat this part. I come here. Now how do I know this is the last symbol of this half? Now I can't see blank. I have to take care of this. I have to consider this as my blank. Replacing crossing. Huh. Huh. Yeah, it will work. Okay, but it's a slightly roundabout way of doing it. Your idea is fine. You need to discard half. Okay. Now there can be a simpler way of discarding half portion. Can you think of it? Huh? Blank. What you replace with doesn't matter. Which half portion you discard? Um, okay. Okay. We don't have much time. See, simpler way of discarding half portion is you need not go to the end of the string and then replace with some symbol and then discard that half and then again overwrite these symbols back to zeros and again see if it is the half or not. Nothing like that. Simple thing, cross every alternate zero. That's it. If you have 6 zeros, I start from the beginning, I cross this zero, then I cross this zero, then I cross this zero. Now in the next step, I have 3 zeros. Within this, I cross this zero. But actually, once you get 3, you won't do any crossing. You have an odd number, you will reject it right away. Okay? But suppose you started with 12, you cross alternate, you will get 6. Now within those 6, you cross alternate, then you will get 3, then you reject. Okay? So you crossing alternate zeros is also one way of reducing it to half, right? So you need not reduce only consecutive zeros to half. You can reduce alternate zeros also. That's it. Okay. So that is an easier method. So let's quickly do that. So yeah, so let's take a sample input. So let's say we have 8 zeros. This is anyway power of 2, right? Okay, so now what we do? We cross alternate zeros in this sequence. So I cross this, I cross this, I cross this, and this. Okay, so here 4 zeros are crossed. And then in the remaining 4 zeros, I'll cross 2, alternate 2 zeros. So this is the second zero, and then this is the alternate zero. Okay, so 2 zeros crossed. And so now this is the second zero, I'll cross it. So 1 0 crossed. And I see there is only 1 0 left. So this is my this is a valid string. It will reject it.
But if you cross the zero, like if you have 7 zeros, if you cross the alternate, you get 4. That's an even number. It should accept it because you will get a 1 zero at last.
Just a minute. Yeah, sorry. If you start with 7.
If you cross the alternate zeros, you get 4 zeros remaining. Then 2, then 1. It should accept.
No, why will it accept if I have 7 zeros? 1, 2, 3, 4, 5, 6, 7. I'll cross this. I'll cross this. I'll cross this. I have 4. So what I'm saying is, I will not even cross. I will see it is an odd number. I will reject it. Yeah, odd number, like any DFA, you don't really need to know the exact number, right? Whether the current number of zeros are odd or even, that state will tell you, odd state or even state. You don't need to know the exact number. That's all. So you can start with an odd number, or you may hit an odd number in between. At whichever stage you hit the odd number, you will reject it.
started the process is crossing the alternate. So how are you sure that we are starting with the A?
So you're saying we will cross first and then we need to decide. That's what you're saying.
Yes, but that's what we did. Ensure that first the next of the zeros is able. So ensure that first, then start.
Okay. Yes, we need to ensure that. So give me a minute. Yeah. So we will cross. Okay. In the first go, we are crossing. And when you are at this zero, okay, what happens is if I see a blank here, I will understand that this entire string is odd. What I'm doing, I am keeping track of the state. I have seen an odd number of zeros, even number of zeros, odd number of zeros, even number of zeros, odd, even, odd, and then a blank. I reject it. Okay. So you'll understand when we see the state diagram. Okay. So first let's look at the algorithm quickly. So the algorithm of this machine is on input string W. First sweep left to right across the tape, crossing off alternate zeros. If in stage 1 the tape contained a single zero, accept. If in stage 1 the tape contained more than a single zero, and the number of zeros was odd, reject. Return the head to the left hand end of the tape. And again go to stage 1. Okay. So before I show you the state diagram, let me give its formal description. Like in DFA, NFA, we give meanings to each state. Here also we need to give meaning to each state. So Q0 is the start state. No zeros seen so far. Q1 means you saw only 1 0. Q2 means you have seen even number of zeros greater than or equal to 2. Q3 means you have seen odd number of zeros greater than or equal to 3. You see, we can have only two states, even number of zeros, odd number of zeros. But odd number of zeros, we need to distinguish between 1 0 and greater 3 or more zeros. So we have two states for odd number of zeros. Because when I have only 1 0, I need to accept it. When I have 3 or more zeros, I need to reject it. Okay, so we have two states to cover both those cases. And Q4 is for leftward movement. That is, we are not solving this problem in one iteration, right? First, we are crossing off alternate zeros, and again we are going to the beginning, and again crossing off remaining alternate zeros, and so on. So once you reach the end of the tape, end of the input, you need to just go left, nothing else. So there is one state where you are just going one step at a time left in a loop. So that is Q4. And QA is accept state. And QR is reject state. Okay. So for leftward movement, we have a state. What about rightward movement? Do we need a state? No. Why? Because these states, whatever you are doing, you are automatically going right side. When you are crossing alternate zeros, you are anyway going right side. Okay. And Q is these states, Q0, Q1, Q2, Q3, Q4, Q accept, and Q reject. What is sigma? Huh? What is the input alphabet? 0. You have strings only with zeros. The language, whatever strings are allowed in the language, those characters only constitute the input alphabet. That's it. Don't worry about anything else. What is the tape alphabet? 0, blank, and cross. If you cross a 0, that also will go on to the tape. And we will also have an additional symbol hash that is to indicate the left end of the tape. So how do you know you reach the left end of the tape? You need a marker. It's like $. Okay, $ for PDA. Similarly, here we have hash. Okay, and delta we will give in the next page. So delta is the following state diagram. Okay. So first we start with Q0. The first 0 I replace with a hash to indicate that this is the left end of the tape. Okay, it's like a marker. So 0 I replace with a hash, and then I move one step right. Okay, I go to Q1. Now Q1 means I have seen 1 0. Okay, I will see one more 0 and cross it off and go to Q2. So the next 0 I see, I cross it and I go right. I'll go to Q2. Okay, now I will see one more 0. I will skip it and cross the next 0. Okay, but if I see one more 0, it means I have seen odd number of zeros greater than or equal to 3. So I go to Q3. I see this 0. I will just skip it. I will not override it with anything. So I will write it as 0 arrow R. So 0 arrow R is a shorthand for 0, arrow 0, comma R. So if you are not replacing the symbol, you're just reading it and going to the next step. So we need not write again 0 is replaced with 0 and it went to right. We just say 0 arrow R or 0 arrow L, whatever it is. Okay. Now I'm in Q3, which means I have seen odd number of zeros, 3 or more odd number of zeros. Now I need to cross off the next 0. And then which state should I go to? I have seen even number of zeros. So I should go back to Q2, right? Can someone close the door? So I cross this 0 and I go right further. So now I'll continue this cycle. For every even 0, I'm crossing. Okay. Now, this is the first time when you are doing it. You are seeing zeros and crossing and going on. Okay. Now, you need to come back. You need to go left. All right. So when do you go left? When you have seen even number of zeros and you see a blank. So when you are in state Q2, that is you have seen even number of zeros so far, the last 0 will be crossed. And then you see a blank. Then you go one step left and you go to state Q4. Now in this state Q4, you keep going left until you see a hash. On the left, you may see zeros, you may see cross. Okay. So there will be a loop. Whether I see a 0 or cross, I'll keep going left until I see a hash, which means I reach the left end of the tape. Okay. So the moment I see a hash, I take one step right. So where should I go to the moment I see a hash? Huh? Q0 or Q1? Q1, because Q1 already tells you saw a hash and you came to Q1. In Q4, also you saw a hash. So you should come to Q1 after seeing the hash. Okay. All right. Now when you are in Q1 or Q2 or Q3, when you are going right, you may have not only zeros but also cross symbols, right? You should just skip them. So you will have a self loop on each of these states. Whenever you have cross, you just skip it and go right. You have cross, you just skip it and go right. Because as the iterations increase, the cross symbols increase than zeros. So you should handle that also, right? Okay. When is the string set to be accepted? Yes, there is only hash. You have seen hash and you came to Q1. So if you are in Q1, you know there is only hash. And the remaining should be all cross symbols. And after that, you should see a blank. Right? Only then you know the string has ended. Like this. Here, actually, what is happening? It is replaced with hash in the first step itself. So when do I accept? I see a hash and all the remaining zeros are crossed. And I see blank symbols here. Yes. If you are in Q1, you skip all the cross symbols, keep moving right. At some point, you will see a blank symbol. Then you accept the string. Okay. So I accept when I see a blank, and I can go right or left. It doesn't matter. Okay. When do I reject the string? when I see odd number of zeros and I see a blank. Okay, the last zero is odd, the last zero is not crossed, which means I've seen odd number of zeros and immediately I saw a blank. If the last zero was crossed and then I see a blank, it means I've seen even number of zeros. Fine, I should go to the next iteration, I should go back. But if the last zero is not crossed, like you asked, I had 7 zeros. Okay, I erased it. Like here I showed, suppose I have 7 zeros. I crossed this, I crossed this, I crossed this. Now I didn't cross this. And then I see a blank, which means I have odd number of zeros in this iteration, I will reject it. Okay, which means if I am in odd state and then I see a blank, I should reject it. If I am in even state and then I see a blank, I should go left to the next iteration. Okay, how do I know if I am in even state? This zero, there will be some even zero that will also be crossed. Now I see a blank, which means this iteration is over, I should go back. Okay. Yeah, so if I'm in Q3 and if I see a blank now, I should reject. Okay, we covered most of the cases, but still there are a few special cases. What if the string is empty? What if you see a blank to begin with? Right? Should you accept it or reject it? Reject it. So if you are in the beginning state and you see a blank, you reject it. But in a Turing machine, like a DFA, we need to have outgoing transition for every symbol on the tape alphabet. So we need to have transition for zeros. For zero, we have a transition. For blank, we have a transition. For cross also, we should have a transition. So this cross also, it will reject. And hash also, it will reject. Because once you have hash, you will never come back to Q0. Q0 means what? I haven't seen any symbol so far. It will not touch cross actually, but in a Turing machine, you have to show transition for every symbol, like DFA. It may or may not get that symbol, but still you should show the transition. Similarly, here also, you should show like so I'm not showing every transition. I'm just indicating that invisible edges which go to the reject state need to be assumed. For the remaining symbols. Okay. Let me close some applications. It seems my battery is low. It's okay. I'll manage. Okay, invisible edges which go to the reject state need to be assumed for the symbol for remaining symbols. Okay, so whatever other transitions that are not shown, you should assume that all those transitions are going to the reject state. Fine. Okay, now let's quickly work out the state diagram for the previous example we discussed. W hash W, you remember, left half of the string should be identical to the right half of the string. So what were we doing? We first read the first symbol, cross it, go to the right half of hash, read that symbol. If it matches with the previous one, cross it, otherwise reject it. So we continue this process in a zigzag fashion. Okay, so that for that language, let's build a Turing machine. W hash W such that W belongs to 0, 1 star. Okay. So like if we have hash and if we have some symbols on the left, we cross all of them. If we have some symbols on the right, we cross all of them if they're matching. Okay. And if we see a blank, we accept the string. Okay. So that's what we were doing. So now let's start with say Q1. Now my string may start with 0 or 1. Okay. I need to take different paths for both sides because I need to remember the exact symbol I see. If I see a 0, later also I should get a 0. If I see a 1, later also I should get a 1. So if I see a 0, I cross it. And I go right and I go to Q2. Okay. Similarly, if I get a 1, I cross it and I go right and I go to Q3. Now, once I see a 0, I cross it. Now I need to go to the right half of the string after hash. So I skip all the remaining symbols up to hash. So in Q2, I skip all zeros and ones and I keep going right. So again, 0, 1, arrow R is a shorthand for both these transitions, 0R and 1R. Okay. Similarly, if I am in this branch, I will keep skipping zeros and ones and keep going right until I see a hash. So when I see a hash, now I am in the second half. Okay. Similarly here also, when I see a hash, I am in the second half. Now, when I'm in the second half, what should I do? I should skip all the crossed symbols and reach the first uncrossed symbol. If that first uncrossed symbol matches with the previous uncrossed symbol that I saw in the left half, then I should go ahead. Okay. So here I should again skip all the crossed symbols. Similarly here. Now I should see an uncrossed symbol if I am in this branch, which means I have seen a 0 earlier. Now also I should see a 0, only then it is matching. Similarly here I have seen a 1 earlier. Now also I should see a 1, only then they are matching. Okay. So I can have a common state where here, if I see a 0, I cross it and what do? I go left. I crossed it, my job is done, I should go left again. Here, if I'm seeing a 1, I cross it, I go left. Okay. Now I should keep going left until I see the first cross. No, first I should see the hash. Then I should enter the left half. And I should keep going left until I see the first cross from the right. I stop there, again start reading the next symbol, uncrossed symbol, compare it, again repeat this entire process. Okay. So first, I will keep going left. Whether I see 0, 1, cross, whatever it is, I will keep going left until I see a hash. That's true. Yeah. You will see only cross symbols. Yes, you're right. Yeah. Yes. So we'll see only cross symbols and then we will see hash. After that, we will see 0, 1. Okay. So after this, we will keep skipping zeros and ones. Okay. We'll keep going left. The moment we see a cross, we go back to the first state. The moment we see a cross, we go right. I stop at the cross, I go one step right. Now I'll see an uncrossed symbol. Now again I start the entire process. I may see a 0, I'll take this branch. I may see a 1, I take this branch. Okay, this is fine. Now when do I accept? Yeah, Q1 on hash. Yeah, right, because when do I accept? When all the symbols are crossed in the left half, when all the symbols are crossed in the right half, and when I see a blank. Okay, so when you see a hash and when you go back to Q1, what do we mean by that? Here also, so here when you are in Q1, if you see a hash, which means here you have seen the last cross and you came to Q1. Now you see a hash. Now you see crosses. You cross all those, you skip all those cross symbols. And if you see a blank, then you accept it. Okay. So I'm in Q1, I saw a hash. Now I go to Q8. I skip all the cross symbols. And now if I see a blank, I accept. Okay. So let me quickly give its formal description. So Q1, Q2, and so on up to Q8, Q accept, Q reject. Okay. And what is sigma? What is sigma of this language? 0, 1. That's it. Hash also is part of the input string here. Okay. And here we don't need to use a marker for the left end of the tape because you are not going up to the left end. You are stopping at the first cross you are seeing. And again, you're traveling right. So you don't need to worry about the left end of the tape. So every problem, you need not worry about the left end. For some problems, you need to know the left end. For some problems, you need not know the left end. This problem, you need not know the left end. Okay. So here, this is 0, 1, hash, and cross, and blank. Okay. Sorry. Left end of the tape. Like, this is the left end of the tape, no? I need not go up to this point every time. Suppose if I have 3 crosses and a 0, I stop here while coming from left. I won't go up to here. So I don't need to put a marker at the left end. Okay. Okay. So again here, Q reject is not shown. Not shown in the diagram. But needs to be assumed. All the outgoing transitions on a particular symbol from a given state if not shown here will be going to the reject state. Okay. So yeah, any doubts? Yeah. Because before the hash, you won't see 0 or 1. You are in the right half. Suppose this, you have a 0, 1, 0, whatever. You crossed this 0. Now you are going left. Until you see this hash, you don't see 0 or 1. That's why. Okay. This is delta. I mean, delta can be represented as basically this diagram will be translated into delta, right? Delta, this state, this symbol, this input, this will be output. Same thing. So right now you can just use this diagram as delta. Okay.